All right, welcome back. We are going to be doing lesson 6.4, which is called leap year. And then I'm going to have you guys do jumpstart in class. And basically, you're going to be defining and drawing a picture of a circle, an angle of rotation, and what they think a degree is, or you think. So today, you'll be able to write precise definitions of rigid transformations and then answer the questions: how do I use my intuition and the insights gained during the past few tasks to identify or produce a rigid transformation? How can I make my intuitive and insightful thinking explicit in words and diagrams? And lastly, what can I add to the words slide, flip, and turn to more precisely define the rigid transformation, translation, reflection, and rotations? So first of all, what is wrong with the words slide, flip, and turn? Like as words for defining rigid transformation. So slide, flip, and turn are verbs and they describe an action. So here are ways the words might be used in a sentence. Slide over here for a minute. Flip the card over so we can see which card it is. Turn the lid clockwise to open the jar. Think about the words you did in class with leaping lizard and leapfrog. What is missing in each sentence that would need to be included to make these actions a translation, a reflection, or rotation? So if you scroll back, especially to leapfrog, okay, a little bit in leaping lizard, but not necessarily completely. But in leapfrog, when you translate something, you need more information, right? Because if I told you to move over here, a translation would be more specific, like um, move 4 units to the right, something like that. So, so the problem with the words slide, flip, and turn is mathematically they're not precise enough. So when we have a slide, we need to describe the distance and the direction. Like if I told you this rectangle, I need you to slide it over. I need you to tell me where you want me to slide it and how far you want me to slide it, in what direction, right? Then it becomes more precise. If I tell you to flip it, I need you to give me kind of like a defined line of reflection. So I think in 6.3, when we were doing some of the homework problems, they gave you a line of reflection that they wanted you to reflect that point across so that they can, um, so you can see that point, right? So they gave you a defined line of reflection. You can't just say reflect. Imagine if I said this, right? Um, Here is, I don't know, a triangle. And I said, reflect that triangle. The first question you should ask is, reflect it across what, right? So whenever I'm asking for a reflection, I need a mirror. So are you saying, like, do you want the mirror here? Do you want the mirror here? I mean, even you can even be like, hey, do you want the mirror here? And it's going to reflect, but it's going to reflect and it's almost going to look like it stays in the same position, but maybe not facing the same direction, right? And then lastly, when you say turn, if I said, hey, I need you to make a turn, right? So let's pretend I was giving you directions and I said, I need you to make a turn. I need you to turn onto, I don't know, Firestone or something. So if I told you to turn onto Firestone, what's the first thing that you're going to say? Wait, which way do you want me to turn? Do you want me to turn right or east? Or do you want me to turn west? Right? Which way do you want me to turn? So the words slide, flip, and turn are good beginning words to use. But as you understand more and more, you're going to need more and more pieces of information in order to do that. Okay. So the word flip can create a misconception, like a wrong way of thinking. So draw a picture to illustrate the sentence. Flip the card over so that we can see which card it is. And be as accurate as possible when drawing the two pictures of the card. Okay. So So let's pretend you have a deck of cards. Here's my deck. Oh, that does not look like a rectangle at all, but let's just pretend that's a really good rectangle. Okay. And let's pretend, I don't know, gosh, if I draw like one of the face cards, it's going to be really hard to draw. So let me just draw the ace of spades. So I think the ace of spades looks like this. Has an ace, it has a big old like, and now I'm thinking, why didn't I just draw the diamond? Because that would have been so much easier, right? So if that's my ace and I tell you to flip the card over, so pretend first you have this deck of cards and it's right here. When you flip it over, it looks like this. But let's pretend that we can actually pretend to see inside that card. So we flip it over, right? So it would look like, oh gosh, Miss Johnson's going to have a hard time drawing this, right? Okay, pretend it's the same size, okay? So do you see what flip means? When we flip the card over, technically you're going from seen to unseen or unseen to seen. Does that make sense? So a reflection is a translation of points in a plane that don't technically move like above. You literally are flipping it across. So if you see, and maybe I shouldn't use an ace because an A is both forwards and backwards. So maybe if I used a 2 here, let's try again. So if I had 2 cards like this, and I'm doing the 2 of spades, it looks like this, right? Oh, let's do diamonds. Ha, ha, ha. So I think the 2 diamonds look like this, right? And then when I flip it across this, oh man, Miss Johnson's going to have to write 2s that are backwards. This is going to be funny. Should have chosen like the number 4. Okay, that's fine. We're still going to learn how to do this. Do you see what I'm saying? Like the 2s are backwards. Hopefully you guys are seeing what I'm saying, right? So that's what it means to flip the card, right? When we say flip the cards, when we're actually playing cards, it doesn't mean what we show here, right? So this is actually called a reflection. These are examples of reflections. When you actually have a deck of cards that's face down and you flip a card over, that's what that outside of math class, that's what flip means. So now our pictures show a reflection. If we actually drew the cards, one of them face down and then one of them, showing, and you flipped it. This is a flip, right? And now it's like, whatever. Let's see. A 5 of diamonds. Uh-oh, how does a 5 of diamonds look? Ooh, I think it looks like this. 1, 2, 3, 4, like this, right? This is what a 5 of diamonds look like, right? And then, so this is the designs. This side is face down. So you can't see what is being there. So when you flip a card, it went from face down to face up. But that's not what a reflection looks like. A reflection looks like this. These 2 are reflections here. Hopefully it makes sense. All right, back to Carlos and Corita. So they are discussing their latest business venture with their friend Juanita. Man, they're always very entrepreneurial. They have created a daily planner that is both educational and entertaining. The planner consists of a pad of 365 pages bound together, one for each day of the year. The planner is entertaining because images along the bottom of the page form a flip book animation when tumbling through rapidly. The planner is educational because each page contains some interesting facts. Each month has a different theme, and the facts for the month have been written to fit the theme. For example, the theme in January is astronomy, the theme for February is mathematics, and the theme for March is ancient civilizations. Carlos and Clarita have learned a lot from researching the facts, and they have enjoyed creating a flipbook animation. The twins are excited to share the prototype of their planner with Juanita before sending it to the printing. Juanita, however, has a major concern. Next year is a leap year, Juanita explains. you need 366 pages. So now Carlos and Carlita have the dilemma of needing to create an extra page to insert between February 28th and March 1st. Here are the planner pages they designed. February 28th, and it talks about a circle, angle of rotation. Angle of rotation can also, so those are the facts. And in March 1st, here's the 360 degrees. Okay. So since February's theme is mathematics, Clarita suggests they write the formal definitions of 3 rigid transformations they've been using to create images of the flipbook. How could you complete each of the following definitions? So here's something. So they want you to start off with drawing a picture to show the meaning of the given word. So here, the meaning of the given word is translation. So we need to come up with a pretty good show of translation. So it says first, draw a picture to show the meaning of the given word. So pick a shape, pick a number, pick a letter, pick a something, and show how you would show translation. So maybe I don't know, I'm just going to do the letter, let's see, S. I'll use the letter S. So translation would be, oh, that's not the same. That looks pretty good. Okay. Then it says, share your picture with your partner, add to your drawing to make it clear. So then we can continue. Number 3 says, use the picture to write a definition of the given word. So how would you describe a translation? So one of the definitions that we've talked about is, so a translation of a set of points so locates points at the same distance and direction along parallel lines. So what does this mean? It means this. Like if I took a bunch of points and graphed them this way, all of these points would be the same, except for Miss Johnson does not draw S's that are the same, right? So maybe this looks like this. And so you get all these points that are parallel, okay? So pretend that Miss Johnson actually did a good job of doing that. Actually, I want to almost, yeah, we'll just leave it. Do your words match your picture? Read your words to someone else and listen to their words. Revise your definition to make it better, and revise your definition to make it even better. So here what we're doing is we're just trying to make a better, a really good, a definition of each of these words that you would understand, and so would your classmates. So I'm going to have you guys do this. I'm going to have you guys do translation, rotation, reflection on your own. And I want to make sure that you guys are comfortable with those words. And it's okay if your definition needs to be a little bit better. Like I'm pretty sure none of you would have come up with the definition that I came up with. Actually, I didn't come up with it. That is from your book. But it's okay if it's not as strong. We'll go over your definitions and make them stronger in class. So number 7 says translations, rotation, and reflections are rigid transformations because the 2 things that need to happen in order for them to be considered a rigid transformation is they preserve distance and angle measure. So if you looked at my S that went from here to here, right? So the distance meant like, well, the angle measure. So notice this S doesn't look, excuse me, all big on the top and then little on the bottom. Excuse me. Or if I was translating a rectangle, if I was translating a rectangle here, and all of a sudden I translate it, and now it looks like a, I don't know, like a parallelogram, right? That's not a translation because it's not preserving the angle measurements. Okay. So, words that I would like you to use when you're on, sorry, over here, words that I would like you to use when you're talking about rotation are some, maybe you use the word circle. Remember when the lizard was diving into the mud? Maybe use the word angle for reflection. I'd like you to use words like, let's see, perpendicular. Maybe you can even use the word slope. So, what I want you to do is come up with your best definition in order to find that. Okay. And it doesn't need to be perfect. It just needs to be, make sure that you are comfortable with um, being able to denote those things. Okay. Thanks for listening.